Hello, everyone. I'm Andrew Sutherland. I'm really excited to be here in Edinburgh, and I wanted to just tell you a little bit about myself first. So I've been a longtime Haskell programmer and worked with compilers and tooling for that time. And I am the technical lead for the Plutus team here at IOG. And basically, I came to IOG because of my passion for Haskell. That's why I'm here. But the thing I want to tell you is what I discovered when I got here, and that's the community. And so the community, being part of this amazing community that's building Cardano, that is incredibly passionate about technology and wants to change the world. And it is just this amazing combination of smarts and desire to do good things. So it's just great to be here. It's an honor to be back in Edinburgh. This is where Plutus was originally launched, so I think it was 4 years ago there was Plutus Fest. And unfortunately, I wasn't involved at that time, but I get to be here today and tell you about Plutus version 2. So let's dive into it and talk about smart contracts. So just quick, a little bit of context. What are smart contracts? Where does Plutus fit in? Basically, at the highest level, developers who are building DApps on the Cardano platform. The on-chain portion of that is the smart contracts, and those smart contracts are actually programmed via Plutus and the extended UTXO model. So there's been a number of people that have mentioned EUTXO in the various talks over the last 2 days. I want to just quickly say something about what that is for anyone that's just not familiar. So the UTXO model, that's the transaction model in Bitcoin, the accounting model. And the way to think of it is it's like coins. It's coins in your pocket. An individual UTXO is a spendable portion of value. We've extended that. The extended UTXO is where Plutus comes in. So you can take those coins that you could spend, the UTXOs, and you can add a Plutus script to it. And so this Plutus script now is what controls whether that coin can be spent or cannot be spent. So that's the basic model that Plutus fits in. And I'm going to dive a little bit deeper into the Plutus portion of it. So what is it? So for the program language nerds, it's an extensible, pure functional language based on the lambda calculus. What does it all mean? Really, the key takeaway from this is Plutus was designed to be secure. That's the number one sort of goal that we started with 4 years ago. Where did it come from? Well, partially it came from right here in Edinburgh, but it's the world-class researchers in programming languages came together and designed, again, with security. We get the security right first, and then we can go on to optimize performance and all the other things, and the functionality. We can increase functionality. So the goal was to design this very small core language that could be highly secure, and then over time, we extend it with additional functionality, and we make the tooling better and better so it's higher performance. Where are we going with Plutus? Part of this design was that it's extensible. So just like on Cardano, we extend Cardano using the hard fork combinator to go to successive eras. And Plutus has the same capability to be extensible as well. So let me dive into that a little bit and tell you more about how that works. So the evolution of Plutus. So this is now looking back. So a year ago, we launched in the Alonso Era. That was when Plutus hit the main net. And since then, one of the interesting things is we've seen on average about 500,000, 500,000 Plutus scripts or more have been executed each month. And part of the reason that I know that is that our team actually uses those scripts. We have a nightly regression system that takes all the existing scripts and runs them to check the implementation of the new code that we're working on. So we're always focused on quality there. Simon talked some more in the previous talk about the formal methods and certification. We also use formal methods in the Plutus team, both to the formalization of the Plutus evaluator. That's another way that we're doing quality assurance testing to make sure that the evaluator conforms to the specifications. And then we also have formal proofs that are derived from the specifications themselves. And that's how we make sure that the design of the evaluator conforms to the specifications. One of the things that we've been doing recently, we've been working on a conformance test suite. And this also ties back into the certification story in the previous talk. So Simon mentioned that there's a third party who's implementing the semantics in the K framework, RV. And this is a test suite that allows them to verify that their third-party implementation is conformant with the specifications. So this is useful for auditors, it's useful for tool builders, and it's generally good for the ecosystem as a whole. We've managed to slip in a little bit of performance work in the last year. The Plutus compiler has been optimized, and we've been able to squeeze about 30% of additional efficiency out of the Plutus scripts. So that's great for the community, and everyone always wants to be able to do more code. Let's see. So the Babbage Era. So we've just had the Vasil hard fork, which brings us into the Babbage Era. This is where Plutus V2 comes in. So this is kind of the meat of the talk here. One of the new features, for signature verification. Kevin Hammond on the Node talk spoke to this to some degree. We've added the SecP 256K1 primitive. This is the signature algorithm that Bitcoin uses, and this is really helpful to enable bridges and sidechains. So that's part of the overall story of extending the reach of the Cardano ecosystem into all these other layer 2 networks or bridges to other L1s. A number of speakers in the last 2 days have talked about CIPs, the Cardano improvement proposals. Plutus is definitely very involved with this as well. There's 3 CIPs that are really interesting for the community and that definitely will impact Plutus, and I'm going to talk about those in a few minutes. Basically, reference inputs, inline datums, and reference scripts. I just want to highlight the CIP process because for the Plutus team, this is one of the really key sources of information and direction. This helps steer the work that we do to solve problems that the community finds to be the most important. So it's really, for DApp developers out there, please do get involved in the CIP process. If there's things that you want out of Plutus, different signature algorithms, different use cases, dive in and get involved, because it's part of the evolution of Plutus to become a really community-driven project. With the new Babbage Era and V2, we've done cost model improvements. So in addition to the 30% compiler improvements on the runtime side, we've also been making improvements to make the runtime more efficient. And as we make the runtime more efficient, we can then pass those cost savings on to the DApp developers in terms of lower cost for executing the scripts. And that's what the cost model is really about. So bottom line, under Plutus V2, it's lower fees for the same script execution. And finally, the script interface. So there's an interface between the Plutus runtime and the node code, the ledger rules in the node. That's the script context interface, and I'll dive into that in a little bit in another slide. But the main thing about this is with V2, we have a more powerful script interface, which means we can exploit new capabilities in the ledger, and that's actually how these CIPs are implemented. I'm not going to dive into all of this. There's just a couple of things I want to highlight. There's really 2 aspects to extensibility, because that's what sort of the story is here. There's Plutus language extensibility. This is where we put in new built-in functions like the SecP 256K1. That gives us the ability to expand Plutus as a language. And then there's this interface extensibility, which I was just talking about with the interface to the node. We get to use new ledger features, and this is how the CIPs fit into this. So what I'd like to do now is just dive into these 3 CIPs a little bit and just give a little more technical detail on those. So first off, reference input, SIP31. This is a really nice feature. It modifies the way that UTXOs are interfaced in transactions. So in the old model, like I said, UTXOs are coins that you can spend. In the old model, the only way that a transaction or a Plutus script could see the coin or see the value or see the data of that coin is it would be forced to spend it. So in this new model with CIP31, there's reference inputs, and a reference input allows the Plutus script to see the value of the UTXO, or more importantly, any data or metadata that's associated with the UTXO. The use case for this that's really key is like an Oracle use case. If you think of, you have one UTXO that's holding some really important data like pricing data, et cetera, and then you have many, many DApps, and each DApps has many, many transactions, and they're all trying to access this one UTXO at the same time. It becomes contention for a resource. With CIP31, now you can put that into a reference input, and all those thousands of transactions, all the different DApps can all access this data at the same time. So that's a really nice feature for scalability. Okay, CIP32, inline datums. So this one gets a little more technical. I'm going to gloss over some of the details, but basically, in the old version, we don't actually store data. Like I was talking about the data on a UTXO for an Oracle. You don't actually store the data in the old version. The only thing you can store is a hash. And what that means is then any off-chain code that's interacting with this has to keep a map from the hashes to the data values. And there's a bunch of just kind of bookkeeping off-chain that's just kind of fiddly to keep track of all this stuff. This allows you to actually put the data itself directly into the UTXO, so it becomes available from the on-chain UTXO without having to do all this off-chain stuff. By itself, it's not a really exciting feature, but the thing about this that's really cool is when you take CIP31, CIP32, it really enables this really cool use case, which is reference scripts. So this is the really big piece for the community about the Plutus V2. So what we can do here is we combine the two previous CIPs. So you have a Plutus script, you put it onto the blockchain using an inline datum, and then you can actually reference it as a script. So it's like a reference input. You're not consuming the Plutus script that's been put on chain. And then you, via using this as a reference script, what it does is it dramatically shrinks the size of the transactions. So I don't actually have to put my Plutus scripts into the transactions. Bottom line takeaway is this just makes transactions much smaller and much cheaper. Let's look at an example here. So here's the case study, MuesliSwap. It's a DEX, a decentralized exchange that runs on Cardano. They took a look at Plutus V1 versus V2. They saw that the size of the transactions were dramatically reduced, 90%, and then the fees were cut by about 50%. So for the community, this is like a really valuable thing. Okay, what's in store? The best is coming up. So here's what we're working on. Coming up soon, we've got additional built-ins for Plutus. We're going to put in more elliptic curve primitives. We're going to put in more arithmetic operators. We're always working on, and we're really trying to increase our focus on developer experience improvements. So the team's working right now on debugging support. This has been a pain point for the community. So we've got a Plutus debugger in the works where you'll be able to step through the Plutus code and you'll be able to eventually examine data values. We're working on more example projects to make it easier to onboard. The Plutus Compiler. Plutus Compiler is always just going to be better, faster, cheaper. And so we think, we've done some profiling, we think there's probably another 30 to 50% performance improvements we can squeeze out of the compiler. And the other thing that we're really interested in looking at is different front ends. So there's a lot of different languages out in the community that people want to use. And what we would eventually like to get to is the point where the Plutus compiler is ready for different front-end languages. That's it's a big project, and it's something that we're really only going to do in concert with the community. That's got to be really a community-led and driven effort. But it's something that we, on the internals of the compiler, we want to move to the point where we're really ready to do that. Finally, Open Plutus Initiative. This is something we've been talking about for a while. It's really all about collaboration with the community, spinning up the developer working groups, getting involved with open source organizations to just continue to broaden the reach and the collaboration with the community. So How to get involved? I've got quite a number of QR codes for you here. So first up, these are for people looking for more information. We've got the Plutus resources. That's our technical documentation. Great place to learn about it if you really don't know. If you're new to the community, we've got the IoG technical community on Discord. That's the place to go to contact us and engage with questions. If you're a developer, you want to go straight to the GitHub repos and just get the code. These are the QR codes for the code. So with that, thank you very much. It's a pleasure to be here.